Okay, let's start. So first of all, welcome everybody. As I said, we are a small circle of person, which is very good for enabling questions and discussions. My name is Michele Colli. I'm an industrial IoT specialist at Force Technology, and I'm here with my colleague Jorg Reder. Today we are going to talk a little bit about the whole maintenance field and how the industrial digital transformation is impacting that and is providing new value creation opportunities. Before we start, I will ask you to keep the microphone off and the camera off. But if you have any question, feel free to write it in the chat section we have here in Teams. And Jorg is going to help me in reading the question and stopping me whenever a question comes up. If you have any comments you would like to elaborate more on, then you just write it and we will give you the word. So you will turn on the mic and make your comment. In terms of practicalities, that's it. We have about 1 hour and my slides will occupy probably about 45 minutes. So we have definitely some time for questions here and there, and feel free to write anytime during the presentation. Once again, my name is Michele Colli. Now I'm talking to you from iDemo Lab, which is, first of all, can you hear me? Can anyone tell me if you can hear me good and see everything good?
Obviously not. Marlene is typing. Yes.
Okay, fantastic, great, fantastic. So I'm talking from iDemo Lab, which is an internal laboratory, open space, which is kind of showcasing some experiments we are doing, some of the technologies from our partners, some of the sensor we use when we build demonstrators, and so on. And as you know, Force Technology is a research and technology organization, or in Denmark, a GTS institute. So we are dealing both with classic consultancy project, but also with innovation projects that are funded by the government. And these webinars are part of one of these projects. So we are going to unfold a little bit what is maintenance today and how it's changing, which type of new value creation opportunities we have thanks to this new Industry 4.0 agenda. So the role of maintenance. Today, maintenance started representing, especially in the past 20 years, a very, very relevant topic for manufacturing companies, and simply because it emerged how maintenance and maintenance operation represent a significant cost driver for production. We are talking about, and there is a lot of research discussing it, and we are talking about between 15 and 40% of production cost, in some industrial areas reaching up even to 60% of the production costs. Now, the issue is that about 65, so 2/3 of the maintenance costs concern either unnecessary or improper maintenance. And 65% means that between 10% and 26% of total production cost is basically waste. It's obviously the key goal today is to try to reduce this 10%, 25% of waste. But the goal is not only the actual reduction of the direct costs of production, but is also to try to improve maintenance, to improve our competitiveness. What do I mean? I mean that today we have a certain need for some new competitiveness advantage. In particular, there is a strong need for shorter and shorter and shorter delivery times that by improving maintenance, we can directly address increasing the asset availability. There is a need for high quality standards, and this is also supported by making sure that we keep quality under control. There is a need for becoming more cost efficient, and maintenance is helping us in this way because it supports an increase of lifetime of our assets, and this also has a sustainable effect. And in the end, last point, but very important, is obviously the need for keeping the work environment safe. There are different ways we have to deal with maintenance, and we call them maintenance policies, and they divide themselves in two main families. So one family is the corrective maintenance policies, which is divided in either deferred or immediate type of maintenance. What does it mean? It means that we have companies that before intervening on their assets wait until something happens, a failure, an unplanned stop, and so on, and they at that point intervene. Deferred is when we wait until something happens, and when something happens, we try to figure out why it happened, what happened, how can we solve it, and so on. Immediate is when we actually have a plan concerning what to do when something happens, and when something happens, we apply that plan. The core aspect of these corrective maintenance policies is that we wait until something happens, so we are reacting. The other family is, on another end, is the preventive maintenance policies family. And this is divided into three main blocks. At the first level, we have time-based maintenance, meaning that we have our schedule, which come from what the vendor of our machines, for instance, is suggesting us. For instance, every 2 weeks, you have to substitute this component. Every 6 months, you have to substitute this other component, and so on. And it, of course, also comes from our own experience with the equipment we have to maintain. So it's based on having a specific schedule that tells us when to maintain what. Of course, there are some limitations and some disadvantages concerning a time-based maintenance, because we are not sure about the effectiveness and especially the efficiency of the maintenance initiatives we are performing. Maybe we are using our equipment particularly good, and we are therefore performing too much maintenance in relation of what would be actually needed, or maybe the opposite. So we are actually overusing our equipment, and we are experiencing failures because we should perform more maintenance than what the schedule is telling us. At this point, we have a more advanced maintenance policy, which is condition-based maintenance. And here it's about collecting data from our assets and try to figure out what is the actual condition of our equipment. And based on the actual condition, we can try to understand if part of the equipment needs maintenance or if part of the equipment does not need any maintenance. And of course, in this way, we can tackle the problem of performing too much or too few maintenance. We will just perform maintenance when we know that we are getting to a critical point. Finally, we have predictive maintenance, which is part of the title of this webinar. And it's also something we hear a lot and we are talking a lot about, even though no one or almost no one is really adopting predictive maintenance. It's still something which is only very mature companies are able to integrate. And it's to some extent built on top of condition-based maintenance, because our interventions are based on actual data that come from our equipment. And we are actually, and this is what we have more than condition-based maintenance, we have the capability to analyze this data and recognize failure patterns and basically figure out, try to forecast when a failure will happen based on the data that we can see today. So if today I see that component 1 has this and this type of temperature, then I know that most likely with a 95% probability in 1 week, it will going to break down. In this way, I can not only intervene when I need to intervene, but I can also make an optimal plan for my interventions in the future. Obviously, today the goal is to move from corrective maintenance policies to preventive maintenance policies. And more specifically, there is a lot of interest in to get to predictive maintenance. What we are seeing today from our projects, from our customers, is that where they are is mostly at a time-based, from time-based to condition-based maintenance transition. So that's the hot point right now, to make that transition. So from time-based, from having a schedule, to start putting sensors on the machine, start collecting data, start figuring out what are the critical components to monitor, what do we need to monitor, and how we can understand when a component is going to break down. So this is the current state of the art, let's say, in manufacturing companies. What about maintenance policies and the selection of maintenance policies? Obviously, it would be suboptimal to have a predictive maintenance on every component we have. It would be over complex, and it would not always bring us the value we expect. So it's important to select the right maintenance policy for the different type of equipment we have in our production. And there are few ways to do that. We will see one way to do that later. But in general, we need to, the decision criterion when we have to select an appropriate maintenance policy is relating four main areas. And one is the damages. So we need to think about the entity and the entity of the damages that are produced by a failure. So if we are thinking about assigning a specific maintenance policy to this piece of equipment, first we need to figure out how damaging is for me if this equipment fails. So damages concerning safety for the plant, for the personnel, for the environment, damages concerning the quality of our products, and damages concerning the profit loss, which is consequent to the production loss we have because our equipment is not running. The second point we need to take care of is the applicability of that particular maintenance policy. Not all of them are applicable in the same way, so we need to consider the internal and external acceptance of that maintenance policy. We have to consider that actual advantages that this maintenance policy can bring us, meaning we know that for some electronic components, the electronic faults they have cannot be predicted. So in that case, it would be pointless to struggle in implementing a predictive maintenance policy since we could not get any benefits from it. And third, the investment needed for implementing that maintenance policy. Third area that we would have to pay attention to is the actual value added by the maintenance strategy. And this could be related to the competitive advantage that our company gains from implementing that maintenance strategy. For instance, if we know that one of our order winners is the uptime of our equipment that our customer can experience, then we know that the more we will invest into being able to understand and forecast when this equipment is going to be down, and the more we will have a competitive advantage in our market. And fourth, the cost of sustaining the maintenance strategy. So obviously we have a cost in implementing the strategy. So for instance, putting sensors on the machine and buying computerized maintenance management software and so on. But another type of cost is the cost of sustaining it over time. So spare part needs, the personnel we need to perform this type of strategy, the software subscription that we need for collect data over time, store them, analyze them, and so on. So we need to take care of these aspects to figure out what is the strategy which is optimal for that specific piece of equipment. Today we have a number of tools that help us in operationalizing, in sustaining these strategies, and these are just two examples and are probably something that you know fairly well. They are used extensively in production industry, and one is the FMECA or FMEA analysis, so failure mode, effect, and criticality analysis, which is an analysis that aims at assessing how critical is a piece of equipment, and also help us in figuring out which type of maintenance strategy we need to choose for that piece of equipment. This assessment criticality is done by assessing three parameters. One is the detectability of a failure, meaning how easy is to identify a failure when this failure happens in our equipment. The severity of the failure, so the damages caused by this failure when it happens, and the occurrence of this failure. So how many times does this failure happen over a month, over a year? By multiplying these three parameters, we will get basically some values that will help us in prioritizing maintenance activities on one piece of equipment or the other. The second tool that we use a lot when we deal with maintenance in production is a computerized maintenance management system. And this is basically an asset management software that helps us in linking all our components, all our bill of material, all our equipment, its maintenance needs, the spare parts stocks, and then it builds a maintenance schedule, which makes possible for us to perform all the maintenance activities according to a specific schedule when we need to perform them. Even these tools today are changing. There is a lot of research looking into a dynamic FMECA, so this type of analysis, but made dynamically, because today what happens is that when we buy a piece of equipment, we make a new FMECA. And once we identify the different priorities in terms of maintenance activities, that's it. That's going to remain there. However, we have to consider that in production environments, environmental factors change a lot. For instance, we have a new employee doing maintenance. We have different spare parts from a different supplier with different reliability. So the question was, what if the environment changes, but we are not changing our priorities when we perform maintenance? This would lead to suboptimal maintenance initiatives, maintenance activities, maintenance plans. So the idea now at the moment, when we look into FMECA, is to have a periodical update of these analysis and of its parameters. And this is, there is research looking into automating this by collecting data from the machines, collecting data from our software regulating maintenance initiatives, and figuring out if something is becoming more critical or less critical. From a computerized maintenance management system side, what is evolving right now is the automatic data collections from the assets. So if today we are manually introducing all the data concerning our maintenance activities, this in the future will be automated. So this is where we're moving towards. However, many questions remain even though we have these tools supporting us. And they go from when is it best to maintain my assets? Am I doing too much or too few maintenance on my assets? How much value could I get if I improve the way I do maintenance, and so on? And today, the whole Industry 4.0 umbrella, this whole digitalization agenda, is providing us with new capabilities for answering these questions. So what we have new is the fact, long story short, is the fact that we can collect data from our assets, we can share data remotely, and we can analyze this data. And this is the big news. It was possible also yesterday, yes. Today is simply cheaper and easier to do that. So the scale is growing exponentially. How do we answer this question? While having these new capabilities help us in facilitating the traceability of critical components, in measuring the current operating conditions of critical components, in having a record of the failures we experience, not anymore on a piece of paper that will be thrown away at the end of the day, but having a record that we can analyze afterwards. Estimating assets remaining lifetime, quantifying the impact of these failures on cost, quality, speed, and other performance indicator, and so on, and formulating improvement initiatives. Now, the foundation, the common ground between all these new capabilities is the fact that they are all enabled by the availability of data from the equipment we have. And once again, this was possible yesterday, yes, but today it's way more accessible. What is the promise? We saw what was the cost of maintenance for us today, more or less, and the promise is to be able, using all these new capabilities, to reduce it by between 10 and 40%. How do we collect all this data? Okay, that's good. We have a lot of room for improvement. We have a promise of 10 to 40% reduction of this cost. So we know that this is being enabled by collecting and using these data. So where are these data? How do we collect them? When we think about production equipment, there are three possible scenarios, three main general scenarios. And one is that the data is already generated by sensors that are embedded in our production equipment. So we have our machine. Our machine, in order to function, has a number of sensors that are connected to our PLC. We have our PLC code. We have our actuators, and the thing here is to basically connect to this PLC, find the data from the sensor we want to monitor, and get this data. The second possible scenario is that data is generated by sensor that we add now on the machine, and we collect on the PLC. And the third possible scenario is that we don't talk with the PLC. We simply build a box with sensor that we want to add to our machine, and then we have these sensors communicating to us, to our cloud computing platform, to our dashboards, to our databases independently. So these are the three main scenarios. What are the application cases when we collect this data? What can we do with this data? Well, we can do plenty of things, but there are three main application cases we can see in industry concerning this equipment conditions monitoring. One of them is to improve the maintenance policy. So we saw how we can go from, for instance, time-based to condition-based maintenance, which is the big transition which is happening right now in manufacturing companies. So instead of having our schedule, predetermined schedule, we start collecting data, figuring out which type of parameters we need to monitor to see if the equipment is in critical conditions, and then have these parameters available to our maintenance team to decide when to perform maintenance activities. The second family of application cases concern the improvement of reactivity of our support operations. Why? Can't we avoid all the failures if we improve our maintenance policy to the top one? No, we cannot, because failures are of stochastic nature, which means that no matter what, at some point, some failures will happen. So another field of application of this data is to actually be as ready as you can and as quick as you can in solving errors when they happen. And the third one is to use this data for problem analysis. So what we were saying when we mentioned this being able of collecting failure data, storing them, and being able to analyze them afterwards and aggregate them. Well, this is interesting because it makes possible for us, of course, to have a way to look back and figure out what is more critical, what is less critical, why do we have these criticalities, and figure out how we can improve our equipment. So have this kind of proactive data-driven improvements. So these are these three main application cases. Concerning the IT infrastructure, how does it look like? I will not dig into the infrastructure, but here you see an example from a paper from Cavalieri and Salafia from Italy, actually from the University of Bergamo, concerning, this comes from a case study concerning the IT infrastructure used for condition-based maintenance. And what we can see is that we have three main blocks. One concerned the condition monitoring aspect. So we have to take care of the critical parameters to monitor in order to assess the current health of the equipment. So which sensors, which parameters are interesting for us, what are the threshold levels we have to take care of, and so on. The second block concerns the connection between these parameters we are collecting from different types of equipment to our information system, which has information concerning the identity of this equipment and the equipment specifications. And the third block concerns the actual outcome of analyzing and having available all these data. So the maintenance schedule. So how do we go from having all this data to a need for a maintenance intervention? If we look into predictive maintenance, we can see how what we have on top of the infrastructure we just saw is this cloud infrastructure where we have a machine learning algorithms that can analyze this data and recognize failure patterns. So in this way, we will be able to do some active forecasting of the failures and figure out when they are going to happen based on the data we are observing right now. Do you have any questions regarding that or not? And now I have an industrial case which is we have been working with it a couple of years ago, and it's collecting I would say 2 out of 3 of these main application cases concerning data for supporting maintenance. And well, the case, the context is a Danish automation solution provider located in northern Jutland, and we have been collaborating with them a couple of years ago. And what they do is taking care of design, manufacturing, installation, and service of automation cells. So when a company wants to automate any production process, they call this company and they ask for a feasibility analysis and for a project for automating that process. And this company design an automation cell which is able to automate that process. Now, in this business, service is a key order winner, meaning that the capability to keep the uptime of your customers high is the way you win your orders. And this company at the moment has more than 1,000 automation cells around Denmark, but also in US, in Central Europe, and so on. And now the complexity related to service and maintenance operation is significantly increasing. And what the company would like to do is to improve their efficiency in terms of maintenance initiatives, being more reactive when any unplanned failure happens at their customer, and being able to analyze the data from all the failures that happen around the world and figure out how they could improve these automation cells. So the idea, what happened at the time was that anytime an unplanned failure was happening at one of their customers, the customer was first trying to figure out what caused the failures. So the production line stops. Why did it stop? It took some time to figure out that it was this company's automation cell causing the problem. And at that point, what was happening was that the customer tried by themselves to solve the problem, completely deleting the error log and maybe compromising even more the automation cell. Only when figuring out that they were not able to solve the problem, they were calling the company. And at this point in time, it was fairly challenging for the company to get back to the original error log, understand what was the issue, and try to guide via phone the customer in solving the problem. So they wanted to become smarter in dealing with this. What we have been doing was to develop an infrastructure that was capable of collecting the right data, meaning what was relevant for the maintenance team to know for solving problems from these automation cells, push this data through a gateway on the cloud. And for cloud, I mean a cloud computing platform. In our case, we used Microsoft Azure to collect this data, filter this data, analyze this data. And finally, shipping this data from our cloud computing platform to a BI tool. We use Microsoft Power BI and Microsoft Power BI app to be able to build a dashboard which was visible for the maintenance and service team from our case company here, and supported the maintenance and service team in performing their troubleshooting activities and their error solving activities. So this infrastructure consisted in few blocks. I will not dig also into this, but I will just give you an overview of what is this consisting of. So we have one layer of concerning data generation and data collection. And in this case, we had sensors embedded in the equipment. So all the relevant information for us were already collected by sensors that the equipment had. We had a data transmission layer. We used a gateway and we used OPC UA to transmit data from our machine PLC to our cloud computing platform. We had some data storage to build a database that we could access afterwards and analyze afterwards. We had the actual data analysis and filtering in our cloud computing platform, so in Microsoft Azure. And we had some data visualization in Microsoft Power BI, and having also an app to have some notifications, some push notification in case of failures. Now, all this helped us in supporting our data use and ultimately our service decisions and actions. How did it work? In the end, it looked like this. So we had a dashboard showing, this is actually coming from a demonstrator we did before implementing it on the actual automation cells. and the demonstrator had been made in the Smart Production Lab at Aalborg University here in Denmark. So there was the dashboard showing the model of the machine. And here, colored in green, you can see the 5 components we were monitoring. On the left, you can see the error database, which is empty, because here we are in a default condition, so no errors. Anytime an error was experienced, we had a well-defined alert thresholds, and we received an alert notification, which consisted in this case of an email telling you, you experienced an error on this machine, this is the error number, and if you click here, you can get to the dashboard of that specific machine. You can see that it was possible to get to the dashboard and see on the left in the error database the list of errors that have been experienced with the specification of the errors, whatever you would like to know. And on the right, the model of the machine with colored in red the component where we experienced the error. Now, the company was actually very happy in having this for various reasons. Of course, it was good for them to have a notification whenever something was happening at one of their customers. Why? Because they didn't have to wait for the customer to call them after trying to fix the solution, after recognizing that it was their fault and so on. But they simply received the notification at the exact time when a failure was happening, and they were actually actively calling their customers saying, hey, I know that on your machine number 2, this happened, you have to fix it like this. Secondly, they were very happy about having all these errors collected in a database for future analysis. And thirdly, they were happy about having this visual aspect, so having this machine model where they could see colored in red where the error was, because that made way easier for them to guide their customer towards the error to be solved, towards the right component, because they had the visual assistance. Concerning the proactive analysis, since they had this database collecting all the errors that they experienced, they said, okay, now that we became more reactive in dealing with unplanned stops at our customers, how can we figure out how to improve our automation cells? Well, let's try to analyze all the errors, all the information that we collected over time. And this is information coming from three automation cells, where we can see on top the 2 different products that have been produced and how many of each product have been produced. We can see in the middle the production lead time variation for each product. And we can see in the bottom all the errors that have been experienced and their repartition and the downtime repartition concerning each error. Now, this made possible for the company to figure out that, well, we have some criticalities here. We know that on that specific day, we produced a very low amount of products. And we know that on these other 2 days, we have a fairly high lead time. And especially, we know that we have one error here on the bottom on the left, which is basically causing 50% of downtime. So we know that if we want to improve our production equipment, if we want to get to a higher performance in production, we need to address that specific error because we have a 50% improvement potential there. So this was very useful for them as well. In the end, as you can see, it was not only about this 10 to 40% reduction of maintenance cost that we saw in the beginning, because the effect of this type of project for them was on productivity, was on a reduction of machine downtime, was on the reduction of cost for spare part inventory holding, because now they knew when they had to go there and solve something. And of course, it was supporting their quality. To wrap it up a little bit, there is something that is very important to consider when we address this type of project, when we address smart maintenance and the use of data for improving maintenance. And of course, on one hand, we have the downtime cost. And we also saw it in this example. So we invest our money in improving the way we do maintenance, in putting sensors, in collecting data, in analyzing data. This as a cost. And we invest it because we reduce our downtime. So we reduce the cost, which is related to the unavailability of my production assets. If our production assets are not available because they have an issue, it means that I'm missing profit because I have a capacity loss. And it means that I have also an image and competitive advantage loss because I increase my delivery time, I lower my quality, and so on. However, we experienced lately a company that told us, well, but I don't have any downtime. So I have a fairly basic maintenance policy because I have a time-based maintenance, and I have my schedule, and doing maintenance as I do it today, I basically have no unplanned stops. So my downtime cost is extremely low. Why should I look into improving the way I do maintenance? Why should I care about try to get more mature, more digital, and so on? Well, because you have another family of costs, and these are, of course, the cost of the resources that I deploy for performing maintenance. We saw that 65% of the maintenance cost we have today are due to either unnecessary or improper maintenance. What does it mean? It means that, well, maybe you don't have any failure, but maybe that's because you're doing not the amount of maintenance you should be doing, but you're doing 3 times the amount of maintenance you should be doing, but you don't know. So you are spending time because you need time for repairing things, for substituting components. You need people for performing these maintenance activities, and you need spare parts, which imply a stock cost, a warehousing operation cost, a spare part cost, and so on. So we need to remember that we have these 2 big families of costs that we need to think about when we think about improving maintenance using digital technologies. One is, yes, the downtime, but the other one is the cost of our maintenance activities. Just to conclude, a small bonus, and here we are talking about external maintenance, meaning maintenance on equipment which we are selling to someone else. While what we discussed up to now is valid both for external maintenance or internal maintenance, so maintenance on our own equipment. To have this data availability concerning how the equipment is working is actually enabling also new business models. One example is the as-a-service business model, meaning that if I'm a machine producer and I sell my machine, and I'm able to see how much and how good a machine has been used, I can decide to lease or rent the machine to my customers and make them pay for what they use it. So for instance, counting the number of cycles and so on. So I will bill them for the actual use. And this is a classic servitized business model, which is enabled by condition monitoring. Another aspect is the warranty claim validation. We have many companies that are interested in making sure that their equipment is being used properly by their customers, because when they claim for some warranty reparation, well, we want to make sure that they're not the breakdowns are not due to a misuse of the equipment. Otherwise, we are not going to pay for them. And the third area is actually related to the whole sustainability agenda and concern a circular business model. So the fact that we know how our equipment has been used when it's outside our factories makes possible for us to figure out if it could be interesting from a business perspective to take it back, to buy it back, for instance, from our customers when they finish using it. If the conditions are very good, for instance, there could be a very good business case in taking the equipment back. But to do so, we need to know what is the actual condition of the equipment and how it has been used when it was out. So this is also something that is enabled having this type of data collection from the equipment. This was actually an example from the industrial case we went through before, which after developing this IoT infrastructure collecting data from the equipment, started looking into a take-back program, and started monitoring all these parameters that they need to monitor to see if they had a business case in taking it back or not. Good, we stayed in the 45 minutes. Thank you very much for now, and I'm open for questions. And also, I would like to know from you if you have which type of maintenance policies you have, and if you are looking for improving them, if you are already using digital technologies to improve the way you do maintenance and so on.
There are no questions from the audience. Are there any questions? I mean, you can, in principle, just open your mic and ask, because we're only like 7 people. If that is not the case, I actually have a question since the beginning almost.
Okay.
And that is, the thing is about implementing predictive maintenance, the hardware is more or less there. I mean, you have many sensors. Sometimes you have them already in the machines. Mm-hmm. Otherwise, there are a huge amount of sensors on the market that you can use for all kind of stuff. And we again and again meet customers that meet us and tell us that they had an issue with the machine. They started looking into it, put some sensors on it. Either they fall off or it didn't really succeeded. Maybe it succeeded and the data was produced, but the whole thing stranded somewhere in the same department. Is there a kind of winning team or who should be involved actually in getting such a project started, but also carried out at the end to make it factory-wide or even globally implemented? I mean, is it top down or up?
Usually it's a very good question, and partly it depends, of course, on the company. In general, what we have been doing a lot is to start involving, for instance, the production manager, maintenance manager, and start understanding what are the strategic goals of the company. So what do they want to improve? They want to improve the reactivity of our maintenance. They want to reduce their maintenance costs. What do they want to do? At that point, what is very important is to be systematic in studying their maintenance process. So what we do is to do an in-depth maintenance operations mapping. So we map all the maintenance tasks and we figure out how long they take, who is involved there, what is the quality ratio of that task, and so on. And we identify what is particularly critical. And when we identify what is critical, then we map all the informations that are needed to address that criticality. And at that point, we engage the actual maintenance operator. So we want to know which type of information are you using or do you need to perform that specific task. And he or she will have a very clear idea of what is the information need.
Yeah.
once the information need is very clear, then it's a matter of locating where are this information located in our system.
Yeah.
And then we can develop an IoT solution and generate this data collection.
That brings me to the next question, actually. Do I necessarily know what the problem is? I mean, is it so that that I can come with a plan like this and this and this is my topic? Please give me a predictive maintenance for it. Or is it actually just the peak of the iceberg or something?
Many times to do this process, this operations mapping and this information flow mapping and so on, most likely it brings up way more application possibilities, and it helps in making many other issues emerge, let's say. So as you mentioned, the tip of the iceberg, yes, you have this tip and you know that you want to address that, but when you start addressing it, you figure out that you have so many other application possibilities. So it's a good exercise also for identifying different application possibilities. Yes.
Yeah. And maybe the last one, where are we? Yeah, plenty of time. Preventive maintenance on the machinery gives me some insight to well, the production flow, so to say, and I can improve the production flow. Is there a chance that I also can go into the processes and actually optimize the processes in the machinery that the machinery is performing by learning more about vibrations, temperatures on the machinery itself? Is there potential for getting actually more than just a production optimization, but actually a process?
I think that is a byproduct, meaning that it kind of goes a bit out of the maintenance domain. So it's probably not what is addressed in the beginning. But of course, the fact that you establish data collection on most likely the critical parameters, because if you need to maintain something, you're monitoring what are the more critical parameters. The fact that you establish this type of data collection and data availability, of course, can help you, can help someone else in looking into the data, in having something to start from when they want to improve something different. So and of course, maybe you will not have all the data you need to improve something different, but you will have a strong basis to do that. Yeah. And we saw it also when we discussed now in the end, we just touched very quickly the fact that you can enable new business models once you have this type of transparency between your equipment and you. So maybe you will need some additional data, but you can always put some sensors on top of that and get some data from these additional sensors. But at least you have a basis.
So at some point, it might be a good idea to draw somebody from development or R&D into the process just to get an idea. Is there something that they can use?
Yes.
For getting further in their own development of the processes that are basis to the production.
For instance, related to that, in the industrial case we saw, the data that came for this kind of, the data that have been collected concerning all the failures. So this big database with all the failures and different parameters for each failures, which made possible for them to see, okay, if I want to improve my production, I should look into this particular error. This is kind of an after sales activity. So it's kind of, okay, I already have my automation cell. I'm using it like this. Is there any way I could improve my productivity by touching my automation cell? Well, good. But having this data could also be a support for the product development, right? So they have data concerning what is failing the most. Well, maybe we should look into that when we design the product. So you can see how this is helping in 2-3 different directions. Yeah. So it's a good point. Yes.
So the business case actually increases from I maintain my machine to bigger parts.
Yes.
So there's something on site. Okay.
I think a very important comment is that and this is at least our philosophy, is that we start by figuring out what is relevant. So we analyze our operations, our processes, and we figure out what is critical. We narrow down, we look into that, we unfold this process, this task, we see which information we need, and we identify then which data we need. But another philosophy would be we collect all data. We collect everything. And then we figure out if we can use it for something. And they are opposite philosophies, and you can see how in research environments, both of them are used. Yeah. Our belief is that in order to reduce complexity, the optimal one is probably the one that we use. So starting from mapping the operations, figuring out, first of all, the strategic goal, then mapping the operations that are interested in the strategic goal, then figure out what is critical, narrow down, map the information flow there, narrow down, find the right data we need to collect. So I think this is fairly important. It's very important to follow this logic when we want to use IoT, enable data collection and transparency to avoid overwhelming complexities, because it's very easy then to get overwhelmed by the amount of data, by the complexity of our digital solutions and so on. Yeah. So that's a good point.
Yeah. So it depends on your maturity within IoT as well. You can be mature in it and pick one specific topic and then maybe spread it out. Or if you're not mature, you ask them the question, what can IoT do for me, more or less?
Yes, yes.
And then you map it out and find the low-hanging fruits to start with.
Yes, but it's really a matter of being systematic.
Yeah.
It's a matter of being systematic.
Okay, I think we filled the hour, right?
Yes. Of course, if you have any questions concerning this, or you want to follow up privately concerning this, this is my contact. I'm available for emails, calls, discussions. It's always interesting to have inputs from companies out there, or from researchers out there. So thank you all for now. Bye bye.